Wiring the future. How leaf-spine networks and automation power the modern cloud. Have you ever wondered how massive data centers, like those powering Google, Netflix, or Amazon, manage to keep billions of data packets flowing smoothly without traffic jams? What kind of road system allows every server to talk to another almost instantly, no matter how far apart they are? Welcome to the world of advanced network architectures, where design elegance meets automation brilliance. Advanced network architectures have evolved to handle the growing demand for high-speed, scalable, and flexible data center operations. Two key developments being the leaf-spine topology and programmable or automated configuration. In a leaf-spine architecture, the network is designed like a simple two-tier fabric. The spine layer consists of high-capacity switches that interconnect all leaf switches, which in turn connect to servers, storage systems, and edge devices. You can imagine it like a modern city's highway system. The spine is the network of expressways connecting multiple neighborhoods, the leaf switches, and each neighborhood has its own local streets connecting individual houses, the servers. Unlike traditional three-tier hierarchies, core, aggregation, and access, this approach ensures that any device connected to a leaf switch can reach any other device with the same number of hops, typically just one or two. This creates predictable low-latency communication, making it ideal for cloud computing, virtualization, and east-west traffic, server-to-server communication, common in modern data centers. It also scales horizontally. When traffic demand grows, administrators simply add more spine or leaf switches without redesigning the entire topology. In practice, companies like Facebook and Microsoft rely on this design to maintain performance as their data centers expand to millions of servers. Complementing this structural innovation is programmable and automated network configuration. Instead of manually configuring switches and routers through command line interfaces, a bit like adjusting each traffic light by hand, modern networks use software-defined networking, SDN, and network automation tools like Ansible, Terraform, or Cisco DNA Center. These systems treat the network as software-defined infrastructure, where administrators define policies and behaviors in code. The network then automatically provisions, monitors, and adjusts itself to meet performance and security goals. For example, if a new virtual machine is launched in a cloud environment, the system can automatically assign it an IP address, configure routing paths, and update firewalls, all in seconds without human intervention. It's like a smart traffic control system that automatically reroutes cars, changes speed limits, and adjusts signals to keep everything flowing smoothly even during rush hour. Together, leaf-spine architectures and programmable automation represent the new era of networking, agile, scalable, and self-optimizing. They reduce human error, accelerate deployment, and support the dynamic workloads of AI, IoT, and cloud-native applications that define the digital landscape today. What do you think? Do you believe automation will eventually replace all human network administrators? Or will it simply elevate their role to one of strategy and oversight? I'd love to hear your thoughts. Please leave a comment below. And if you found this explanation insightful, don't forget to like, share, and subscribe for more deep dives into the technologies shaping our digital future. Thank you for watching. Mahalo.